Okay, so polynomial multiplication. Before we go on, I remind you that you already know what a polynomial is. You did these in the 9th grade. You've actually done, most of you will have done everything we've done for the next couple of days. It won't be new to you. So we're going to go through it pretty quickly. So the first thing is, what is a polynomial? Does anybody know? Please don't give me an example of a polynomial. Please tell me what it is. Does anybody know? Sweet. We did a good job in grade 9. So a polynomial is any combination, and I'm going to write combo because I'm lazy, any combo of variables, which I'm going to highlight because that's one part of it, coefficients, which I'm going to highlight because that's the second part of it, and or constants, which I'm going to highlight because that's the third part of it. Okay, you have to have all three of those things. All right. Now, before I go any further, I'm going to talk about what it doesn't have. There are no irrationals. What do you need, Sean? 5 minutes to what? Where were you for the past 40? I've got 20 people in here and I'm teaching a class right now. So you could ask them, or you could come here at lunch when I sit here for 40 minutes by myself. Next time. No irrationals. Now, we just did a whole unit on irrationals. What are irrationals? That is any square root or cube root or fourth root that doesn't work. Okay? So would the square root of 4 be allowed? Yes, because the square root of 4 is 2. Would the square root of 3 be allowed? No, because 3 has no square root. Everybody cool? So there's no irrationals. That's the first thing. That's not allowed. The next thing is you got to know what all these things are. What is a variable? Do not say X. Do not say A. Do not say Q. What is a variable, Emily? Thank you. A variable is an unknown value that we choose to represent with a letter in math class. Does it have to be a letter? No. When you were first doing math in grade 1 and you were learning addition and you were doing algebra, but your teacher didn't call it that, she showed variables, or he, with a blank. Your textbook had a little square that was shaded in, plus 3 equaled 9. You were supposed to figure out what that little blank was. That's algebra. They didn't call it algebra, but that was algebra. So you were actually doing grade 9 math in kindergarten. But they didn't call it algebra, so when you got to grade 9 and they called it algebra, you could then go, oh, I don't know how to do algebra, even though you've been doing it since kindergarten. So, a variable is an unknown value represented by, repped by a letter. What's a coefficient? I use the word all the time. Somebody must know what it means, or do you just let it wash over you like the ocean? It is next to the variable, but that's not math class. What does it do? Coefficient is the number that multiplies a variable. And a constant is just a number. It's called a constant because it doesn't change. Okay? So, a polynomial that has all three of these things would look like this. 2x plus 7. The variable is highlighted in blue. The coefficient is highlighted in green. And the constant is highlighted in pink. Does everybody understand? Can it have more than one variable? Yes. Can it have more than one coefficient? Yes. Can it have more than one constant? Yes. All right? That is the simplest polynomial that has all three. Everybody cool? All right. Now let's move on to these three words. You need to know what they all mean. A monomial. Mono. One means mono. Okay? One term. We'll define what terms are in a minute. A monomial is a combination of multiplied, nice spelling, multiplied, and I'm going to highlight multiplied because it has to be multiplied, multiplied variables or coefficients. Now, variables and coefficients. Okay, multiplied. So let's do a couple of examples in red. X, is that a variable? How much is it being multiplied by? 1. So is that a variable and a coefficient? So that is a monomial. Everybody cool? Okay, what about this? 2y. Is that a monomial? Why? Because it's got a variable and a coefficient, and they're doing what? Multiplying. Everybody cool? Now here's where somebody's going to get it wrong. Is this a monomial? 2x, y, z. Yes or no? Yes. Why? Because they're variables that are multiplied together. It doesn't matter how many there are. As long as there's only multiplying, it's one term. Even though this has three things in it, it is one term. Everybody cool? All right. So you guys are smart kids. Binomial. 2. Bi means 2, like a bicycle. 2 terms. So a binomial is a combo of 2 monomials. So if one monomial is all multiplied, how do I combine that with another one? They are separated by plus or minus. Everybody okay? So, oops, I want to do the examples in red. X plus 3. Binomial. Single monomial, x. Another monomial, constant, separated by plus and minus. Got it? 3y squared minus 2x. Binomial. That's all multiply, that's all multiply, and there's a plus or a minus between it. Everyone good? 2xy squared z minus 3abc. Still a binomial. because there's only the one separating operation. Cool? All right. So what's a trinomial? 3 terms, which means how many plus or minus signs? So a trinomial is a combo of 3 monomials. And after that, there's no more names. They're just polynomials. There's no quadrinomial and quintinomial. It's just polynomial after that. X squared plus 2x minus 3. XYZ plus ABC plus DEF. All that is still a trinomial. Everybody good? All right. Now, this is all background that you already know. This might be new to you, this term, and it really isn't very important until you get further up and you have very complicated polynomials. For your guys' level, what we're about to talk about isn't that important. I just want to make sure you've seen it in case future math teachers start talking about it. If you were in my grade 9 class, you already have seen this, because I am now your future math teacher, that when I was teaching you, I was not your future math teacher, but I wanted you to know it so your future math teacher could explain it. I am now that future math teacher, and now I'm showing you. Degree of polynomials is very simple. It is the highest sum of variables, of variable exponents in any one term. Okay? So, x plus 3. What is the only exponent that's with a variable in that binomial? 1. X has an exponent of 1, yes? So that has a degree of 1. Everybody with me? This guy is degree 1. What if I have this? X squared plus 3. Now what is he? Degree 2. Everybody cool? Now the only time it gets tricky is when I do something like this. X plus XYZ plus 3. The highest sum of variable exponents in any one term. There's a variable exponents, yes? What is each exponent there? 1, 1, 1. Sum is added up. So what degree is this? That is a third degree polynomial. No, because that guy's only got 1. It's the highest sum in any one term. So because this guy is a 3, 1, 1, 1, this whole polynomial is a degree 3. Okay? The only reason we care about it is when the polynomials get very complicated, we like to write the biggest degree first and then down. That's the only reason. I don't really care if you do it or not. Everybody cool? All right. So now we are moving on. We're going to do something that you should have done last year, but not necessarily everybody did. So technically right now I should hand you out, all of you should get an algebra tile package. Well, each group of you should get an algebra tile package. I'm not totally sold on these. I don't know how necessary it is. I'm going to risk not giving these out, and I'm going to risk showing you how they work. You should have done it last year as well. Why did that happen? There we go. Okay. You should have seen this already. So these algebra tiles, these things mean something. How many of you have seen these before? Good. They were invented to show kids how to do basic algebra when they were unable to figure it out with numbers. Unfortunately, somebody decided that even if you can figure it out with numbers, you should also know how to do it with these things. So someone like my wife has a lot of trouble using these, even though she can do algebra well into university level. But these things mess her up. So I'm going to take a moment, talk about them, and then we're never going to actually touch them again. I'm going to make you draw like 10 pictures with them, and that's going to be it. All right? That is 1. That is -1. Cool? So what do I get there when I put them together? 0. Got it? Algebra tiles have one use. They're good for explaining why subtracting a negative is the same as adding. That's about the only use I have seen for algebra tiles. If that is 1, how long is that? 1, 2, 3, 4, 5. Is it 5? It's just shy of 5, isn't it? So do you know the exact value of this? No. What do we give in math when we don't know something? A variable. So that is x. That is -x. Everybody with me? So this is 2x. Because I have 1x, now it's multiplied by 2. What's that? 3x. What's that? That makes 0, so what's that? 1x. Everybody with me? Everybody with me? All right. Now, what happens if I take that and that? What have I made? No. What have I made? A square. How long is each side? Each side is x, yes? So if the length is x and the width is x, what's the area? X squared. Everybody with me? So that is x squared. That is -x squared. Everybody with me? Okay. I am going to make you do like 10 questions with these, and then we're never going to use them again. Okay? Now you will notice on your notes, the first thing says concretely. Concretely means with actual things, not drawings, not numbers, actual things. Show me what 5x plus 1 looks like. So what does that mean in English class? If I were to explain that in words, what would you say it meant? What's that? 5. Great, everybody knows that word. Excellent. What's that? X plus 1. Great, everybody knows those words. Good. What math is happening right there? Multiplication. What's our word for multiplication? Times. So now that we know all the 3 words involved, somebody try to say this in words. 5 times x plus 1. Yay! All right. Okay, we're all there. Good. So what would x plus 1 look like? The bar. And red or green? Red, because I said reds were positive. A little red square. There's x plus 1, yes? How many of them do I need? 5. Does everybody agree? What's showing on the screen in front of you right now? 5 x's plus 5. Right? Easy peasy lemon squeezy. For some strange reason, there are enough people in the world that can't understand that with numbers that these had to be invented. Okay? Everybody cool? All right. So, we've talked about it concretely. Now we're going to draw it. How do we draw it? We know that this is 5 times x plus 1. So how do we draw it? We draw x plus 1, x plus 1, right? Because I'm going to make the clear ones positive because I don't want to bother coloring them in. X plus 1, 5 times. Right? And then all I got to do is count it out. 5 x's, positive 5 there. The answer is 5x plus 5. If you can't do algebra, you can always draw a picture. I am not putting you down if you draw the pictures. It is fine. However, the pictures are only good up to what size term? X squared. Do we ever have an exponent bigger than 2? Yeah, so you better use these to learn how to do higher level stuff. Got it? All right. So everybody can do the drawing, yes? Okay, so when you turn your page over, you should then see the word algebraically. Oh, it's on your first page? Great. Even better. That word algebraically means no pictures. It means all math. And this is what happens. 5x plus 1. What that means is you need to have, after we drew the pictures, we knew we needed 5 x's and we needed 5 little ones, yes? Because that 5 had to multiply to there and to there. Because this is 5 times both of those things, yes? So we get 5x plus, sorry, I want to draw that differently. 5 times x plus 5 times 1 to get 5x plus 5. And that is what we call the distributive property. Now, a great many of you have probably seen that before. Your teacher probably had a fun little nickname for it. I do not. Your teacher may have called it flying arrows. Your teacher may have called it a various other bunches of things. I will not, because it has a name. Its name is the distributive property. And what it means is this. I'm going to draw it with letters first. X, A plus B equals X times A plus X times B. That's what it means. What you are actually doing is taking a coefficient from in front of a polynomial and multiplying it by each term. Okay? Everybody cool? So your next thing should be this. It might be on the next page, I don't know. Show a picture and an algebra solution. So if I'm doing a picture, you saw what the last picture looked like. We had 5 out here, and we had x plus 1 there, right? 5 down there, 1, 2, 3, 4, 5, and x plus 1 there, correct? So what do I have here? One side is x, yes? How do I draw x? I draw a bar, x, and I leave it uncolored because that's positive. What do I have on the other side of the box? 2 x's. 1, 2, and then I have -4. So I color in 4 of these little guys. Right? What's going to happen here? This x is going to do what? Stretch out, isn't it? To that width, right? How many times is that going to happen? Twice. This bar is going to hit this negative. What wins, positive or negative? Negative. So I'm going to have that, 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 and that. Yes? Here is my answer. What is it? Just count. What is that? 2x squared. What is that? -4x. That's the picture. I also want algebra. In algebra, it looks like this. Distribute. That's the coefficient. It goes there. What is 2 times 1? 2. What is x times x? X squared, because the exponents will add, won't they? We just did a whole unit on that. Minus x times 4 is 4x. Does everybody understand both? Good. Do the next one. What are each sides going to look like? That's a side. That's a side. The answer lives in the middle. And then over here, we're going to do it with algebra. So what does one side look like? 3 bars. Colored or uncolored? Why? Because they're positive. What's the other side look like? 1 bar, 2 little guys, all uncolored. What's the middle look like? Big guy, big guy, big guy. Bar, 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 bar. And the answer's in the middle. All you got to do is count. 3x squared plus 6x. Now come over here and show me with algebra. 3 times 1 is 3. X times x is x squared. Plus 3 times 2 is 6. X times nothing is x. Can everybody do it? You all should have been able to do it in grade 1, but your teachers didn't make you. It's not their fault. So now we come to this situation, which is slightly different. What's different about this? I got binomials on both walls, don't I? So one wall has x plus 3, and the other wall has x plus 2. What's this one going to be? Big X. Then I'm going to get this bar and this bar. Then I'm going to get this bar and this bar and this bar. Then I'm going to get 1, 2, 3, 4, 5, 6, aren't I? Because 1, 1, 2, 2. What is my answer? Answer lives in the middle just like it always does. What is it? X squared plus 5x plus 6. Right? Everybody's good? Okay. Now, this might be new to some of you. Some of you may not have seen this in the 9th grade. So you want to start paying attention now if you haven't been up to now. If up till now you've been like, I got this, no problem. Now you're going to want to start paying attention. So what I had was x plus 3 and x plus 2, yes? Everybody agree? If this 3 was not there, what would you do with that? You would multiply it out and get x squared plus 2x, yes? Everyone agree? Okay. What if this x were not there? What would you do? Multiply it out and get what? 3x plus 6, yes? Positive 3x plus 6, yes? Now, we look at this and we see, hey, okay, they're both there, so I must have to do both of them. What do I get to do? X squared. Hey, I had 5 x's there because there's positive 2 and positive 3. 5x plus 6. Because what is really happening there is x times x plus x times 2 plus 3 times x plus 3 times 2. Everyone understand? Because what's really happening is I have to do that x to both of them. Then I have to do this 3 to both of them. Is everybody cool with that? That is cumbersome. That is ugly. So math guys invented this acronym, FOIL, which stands for first, outside, inside, last. And what that means is x, I don't want to do x. Yeah, I do. X plus A, X plus B. First, I'm going to do that with a black line. You do the first in each term, and you write it out. X squared. Then I'll use a red line. Outsides. The outside one times the outside one, which is plus bx, yes? Then I'll use blue. The inside two plus ax, and then I'll use, what have I not used? Black, red, blue, green. Last, which is AB. And you will notice that I stacked the x's together because they are what we call like terms. Is everybody cool? Now, listen to me and listen to me closely. There is a shortcut to this. Some of you will know it, some of you won't. I'm not going to show you the shortcut until we have done an entire page of doing it the long way. Because, as always, if I show you a shortcut and you forget the shortcut, you're screwed. Because as soon as I say the word shortcut, you all stop paying attention. So we're going to turn the page over. No, not yet. We're going to work right here. So, picture and algebra. Do we need the picture or are people okay? They're okay? All right, I'm going to risk it. So I need an algebraic solution for that. As soon as you see binomial, binomial, you know you've got to distribute twice. If it helps, draw an arrow, write an answer. First, what's x times x? X squared. Outside, what's x times 4? Positive 4x. Inside, what's negative 1 times x? Negative 1x. I'm writing the 1 for a reason. Last, what is negative 1 times positive 4? Negative 4. Please notice I have stacked them. X's together. Why? Because they're like terms and I can combine them. And I get x squared. What is 4 minus 1? Positive 3x. And this guy has nothing with him, so he's negative 4. Can everybody do it? Yes? All right. So turn the page over, and you're going to do this page, which has 1, 2, 3, 4, 5, 6, 7, 8 questions on it. But I want you to make sure, I want you to stop at D, because I'm going to show you the shortcut for E and F. All right? So let's go. Should take you about the time it takes me to put away my algebra tiles. Remember, this is not art class. I'm not giving you bonus points for making these pretty. 3 years ago, I had a kid in my grade 9 class. He was doing this test, and I had a couple of these drawings on it, and everybody else was finished. Like 20 minutes it took. At the end of the class, he still works. Say, dude, what's taking so long? And I walk over and I check. He's gotten out his ruler, and he is drawing perfect boxes for all of them with a ruler. And I'm like, dude, I appreciate your OCD-edness, but it's okay. You don't need to do that. You can sketch it. One side has 4. One side has 3 and minus 2. Big, 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 big. Bar, 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 bar. 12x squared minus 8x. Right? This one. Bar, 1 colored box. Bar, 5 colored boxes. Big one. Bar, 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 bar. 2 negatives make what? Positive. 1, 2, 3, 4, 5. Answer, x squared minus 6x plus 5. Right? Everybody's good, yeah? Okay. Now remember, for these first 4, I want to see the work. So, first one, what's 2x times 2x? 4x squared. Then outside, 2x times 4. 8x. Then inside, negative 4 times 2x. Negative 8x. And last, negative 4 times positive 4. Negative 16. Then what do I do? Collect like terms. 4x squared. 8 minus 8 is what? 0, so they're gone. Minus 16. Cool? Everybody good? Okay. Now look at B. Some of you are going to be tempted by your last test to do this with the 2, aren't you? Aren't you? Is that right? No. Because this means x plus 2, the whole thing, twice. because this whole thing is a base. So first, what's x times x? X squared. Outside, what's x times 2? Plus 2x. Inside, what's 2 times x? Plus 2x. Out last, what's 2 times 2? What do I get? X squared plus 4x plus 4. Everybody cool? What's this one? X squared minus 2x plus 3x minus 6. Collect your like terms. X squared. Negative 2 plus 3 is positive 1x minus 6. And what's this one? X squared minus 7x plus 9x 63. X squared, negative 7 plus 9 is positive 2x minus 63. Now, are you ready for the shortcut? Shortcut only works when x is alone. But not just x, a, b, c. As long as the first thing is by itself, in both of them, this shortcut will work. I want you to notice something. Negative 2 plus 3 got me 1, right? 9 minus 7 got me 2, right? Right? 2 plus 2 got me 4, right? So what's the shortcut for the middle term? Here, with 9 and 4. I know the first one's going to be x squared. What's the middle term going to be? Don't write it out. You don't need to write anything. Negative 2 plus 3. Negative 2 plus 3. Negative 7 plus 9. Negative 7 plus 9. So what's the middle term going to be here? 9 and 4 plus 13x. What's the last term going to be? 2 times 3, 6. 7 times 9, 63. 2 times 2, 4. So this is going to be 36. What's the shortcut? If I have x plus a and x plus b, the answer is x squared plus, and this one is a plus b times x, and this last one is a times b. Does everybody see this? So what's this one going to be? The first number is going to be x squared like it always is. Then what do? Negative 4 and negative 2, which is negative 6 minus 6x, and then times, what's negative 2 times negative 4? Positive 8. Does everybody see the shortcut? If you don't believe me that it works, check it. X squared minus 4x minus 2x plus 8. X squared minus 6x plus 8. Hey! But it only works when? If the first variable is by itself. Okay? Everybody with me? All right. Your homework today, and you have 25 minutes to do it, is your next 2 pages, which for you guys should be 102 and 103? 103, 104. The page that starts polynomial multiplication. Okay? Now, please be careful. There's a couple of weirdo things in it, right? And I'm going to show you what I mean by a couple of weirdo things. Uh-oh, what's happening here? There's 3 of them. So how many stacks do you have to do? 3. What about this one? 3 of them again. So you're going to have to do it 3 times, yeah? Please pay attention. Is there anything new when there's 3? No, it's the same thing. It's like doing, can you do 2 times 5? Yes, it's 10. Can you do 2 times 5 times 5? Yes, it's 50. Nice. My boy's got to play rugby in this today. And if it's happening here at 1, guess what it's going to be doing in Chilliwack at 2:30? This. I have to referee the game. Spectacular! I wonder if it's loud enough to come out on the video. Shh. We'll see. Hey, it turned over. Oh, I stopped. Oh, I just stopped. What happened here? This whole thing has turned over on me. Rotate! Like Wingardium Leviosa. All right. So you guys go.